On tool use by robots, recognition of characteristics of objects is critical. Especially if robots cannot recognize intrinsic characteristics, they may fail to move heavy objects, crush soft objects, and slip low-friction objects. This study is the first work on tool use considering both characteristics of objects. We make the robot to serve meal and construct a deep learning model which realizes active perception and tool use motion generation seamlessly with the same model. Our contributions are as follows. At first, we remotely control the robot to collect training data. In the active perception part, the robot steers the ingredient. In the motion generation part, the robot selects a tool and serves the ingredient. Second, we train the DNN model and the model learns to express the characteristics of objects and tool-object and action relationship in the latent space. At last, in evaluation experiments, after the active perception part, the DNN model explores the value in the latent space. Then, using the explored value, the robot generates motions for serving by itself. The DNN model refers a past study by Saito. Tools and objects used in the experiments are as shown. This is the result of principal component analysis on the latent space. The plots of same ingredients are clustered and their placement shows their proper tool and the way to act. The axis of PC2 expresses tools and PC3 expresses action information. Untrained ingredients are also plotted with numbers. We can assume the recognition of the ingredients' characteristics by the robot from the placement. This is a movie when the robot serves milk, which is untrained. We also show the images of robot's view and images predicted by the DNN model. During the active perception part, the robot predicts characteristics of milk by exploring in the latent space. Then the robot can select the ladle properly and pour milk to the bowl, adjusting its joint angles. The robot succeeded in serving other ingredients too. We are showing the movie where the robot serves untrained ingredients. The robot successfully changed tools to use and adjusts the way to use tools depending on the ingredients. We tested the contribution of sensor data. We found that image was necessary to perceive extrinsic characteristics, and force data was mainly used to perceive intrinsic characteristics. Tactile data was also used for perceive intrinsic characteristics, but it had larger loads in grabbing tools. A variety of multimodality realizes rich perception for adaptive tool use with a variety of objects. Thank you for watching.